Are day 3. This will be your video that you'll get to help you with the problems. And again, remember the problems are numbers 1 through 49 odd in chapter 10. They start on page 307 and end on page 333. I went through and done some of the even problems as examples for you. First problem, we're going to find the number of atoms in C3H8 if we're given 2.12 moles of carbon. Step 1 is to write the given information down, 2.21 moles of carbon. And then in a molecule, in 1 mole of this, there's 6.02 e to the 23rd molecules. And then because it's C3H8, there are 3 atoms of carbon per every molecule. So we take 3 atoms of carbon over that. Since it's on the top, we take 2.12 times 6.02 e to the 23rd times 3. And our final answer, when you multiply that out, will be 3.83 e to the 24 atoms of carbon are present in propane gas. That's example problem 1. Okay, I'm going to erase here and get you started on example problem 2. In example problem 2, we're going to find the molar mass of H2SO4. Now you've done this before. Again, we're going to take the atoms. So if we have hydrogen, sulfur, and oxygen, we have 1 atom of hydrogen, 1 atom of sulfur, and 4 atoms of oxygen. Multiply that each by the atomic mass number from the periodic table. Remember to round one place past the decimal. Multiply them, add them up. 1 plus 32.1 plus 4 times 16 will be 64.0. Add those numbers up, and you get 98.1. Grams per mole, grams, or U are all acceptable units for that problem. Next will be example problem 3. Example problem 3, we were given 3.70 moles of nitrogen gas at STP. Since that's at STP, that means we can use the magic number of 22.4. So we take our 3.7 moles of nitrogen gas as the given. In 1 mole of nitrogen gas at STP, there are 22.4 liters. Moles cancel off. Again, punch that in the calculator, 3.70 times 22.4. And with 3 sig figs, you should get 82.9 liters of gas. Okay. Sample problem number 4. You're given 3.58 grams, and we're going to find out 3.58 grams per liter, and we're going to convert that to grams per mole. Again, if the gas is at STP, we can use 22.4 liters per 1 mole. Liters will cancel off, moles will not cancel off. Moles is what we want to try to find because we're trying to try to find the molar mass of the gas. So 3.58 times 22.4 equals 80.2 grams per mole. And that, of course, equals the molar mass. Next is problem 5. Problem 5, we're going to find the percent of each element, percent of carbon, and the percent of hydrogen in C2H6. So again, the first thing we do is we find the molar mass of C2H6. 2 times 12.0 for carbon, 6 times 1.0 for hydrogen. So that's going to equal 24. That's going to equal 6. So the molar mass is 30. To find the percent of carbon, we take 24 over 30. 24 divided by 30 will equal 80.0%. To find the percent of hydrogen, we will take 6 divided by 30. Remember to use these numbers here. 6 over 30. And of course, that's going to equal 20%. For these problems, there are no measured values, so there are no sig figs, but I like to go one place past the decimal to keep things consistent there. Okay, next problem we're going to go over for you is problem number 6. In problem number 6, we are given 350 grams of C2H6, and we want to find the grams of hydrogen in that. So again, write our given information down first, 350 grams of C2H6. Gram of C2H6 goes on the bottom. Gram of H6 goes on the top. In C2H6 from the last problem, we know that there are 30.0 grams. In H6, there would be 6.0 grams. So 350 times 6 divided by 30 equals 70 grams. We could also, conversely from the previous problem, just taken 350 times 20%, which is 0.20, and get the same answer. Okay, next problem we're going to go over is problem 7. We are going to find the simplest formula, 62.1% carbon, 13.8% hydrogen, and 24.1% nitrogen. Step 1, I'm not going to erase here because I don't have room. You would convert your percentages, just change them to grams. Okay? So we change them all to grams. You probably do that on paper if you have it. Step 2 is to convert them all to moles. We know there's 12 grams of carbon in 1 mole. For hydrogen, we know in 1 mole there's 1.0 grams, and for nitrogen, in 1 mole there are 14.0 grams. So that will give us the following numbers. For carbon, and again, go 3 or 4 places past the decimal, 5.175. For hydrogen, of course, it's going to be 13.8. And for nitrogen, it's going to be 17.21. Divide all 3 of them by the smallest, 17.21, 1.721, 1.721. That'll equal 1. Hydrogen will equal 8, and carbon will equal 3. So then the ratio will be 3 to 8 to 1. So the final answer will be C3H8O. And finally, our last problem to go over sample-wise for this chapter. Chapter 8, you're given CH3O. You're given the fact that it has a molecular mass of 62.0 grams per mole. We want to find out what the mass of this, the actual chemical formula of CH3O is for the compound. So again, find the molar mass of CH3O. That'll be 12. 3 times 1 is going to be 3, and O is going to be 16. 16 times 1, 12 times 1, and 3 times 1 for the number of atoms times the number from the periodic table. Add them up, and you get 31.0. 62.0 divided by 31.0 is going to equal 2. So we have to take 2 times CH3O. So the final answer then for the molecular formula will be C2H6O2. That is your problems from Blizzard Day number 3. If you have any questions, again, shoot me an email. I'll periodically be checking it through the day.